wishes and welcome to the section of grade 10 CBSE mathematics class. Today we are looking at the chapter number 6, triangles. Already we studied the basics of triangles in the 9th grade. In our video section also we discussed lots of things related to triangles in the 9th grade class. If you are having any basic doubts, if you are having any doubts in the basics of triangles, then you can go through the video section of 9th grade. Okay. Now in this chapter, triangles for 10th grade, we have topics related to similarity of triangles and Pythagoras theorem. Similarity of triangles and Pythagoras theorem. Related to similarity of triangles, we have some theorems, and based on that theorems, we can solve some problems. And after that, we will move through Pythagoras theorem and problems related to Pythagoras theorem. Okay. So basically, similarity of triangles. The first theorem you need to study. You have to study. You must study. The first theorem is that if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. So when we are considering a triangle, just consider a triangle. A, B and C. So this is our triangle. If a line is drawn parallel to one side of a triangle, so I am going to draw a line parallel to BC. So this is the line parallel to BC. This line intersects other two sides in distinct point. So this line intersects the side AB at the point D and AC at the point E. So D and E are points on the sides AB and AC respectively. Then the other two sides are divided in the same ratio. If the line DE is parallel to BC, if DE is parallel to BC, if DE parallel to BC, then AB and AC are divided in the same ratio. Then AB and AC are divided in the same ratio. That means we can say that the ratio of AD by AE is equal to BD by EC, which should be same. AD by AE is equal to BD by EC. This should be same. This is the theorem. So, if a line segment is parallel to one side of a triangle and this line segment intersect other two sides in distinct point, then this line segment divides the sides in equal ratio. Otherwise, this theorem can be stated in reverse order. If a line segment divides two sides of a triangle in the same ratio, then that line segment is parallel to the third side. This can be explained in reverse way such that if a line segment divides two sides of a triangle in the same ratio, then this line segment is parallel to the third side. This line segment is parallel to the third side. That's it. Simple. This is the first theorem. Now we need to do problems related to first theorem. Okay. Now moving to the problems related to theorem that we have studied right now. In the figure, DE parallel to BC, then find DC. So this is basically the theorem what we have studied right now. Here DE parallel to BC. DE parallel to BC. We need to find EC. So this is, we need to find EC. How we can find EC? We all know that if a line segment is parallel to the third side or one side of a triangle, intersecting other two sides at distinct points, then the line segment divides the sides in same ratio. So here DE intersects AB and AC at D and E respectively. So the ratio should be same. That we can say that by theorem AD by AE is equal to DB by EC. Substitute the values. What is AD? AD is 1.5 by what is AE? AE is 1 equal to DB. What is DB? DB is 3 divided by EC, that we don't know. Just cross multiply. EC into 1.5, that is 1.5 EC is equal to 3 into 1, that is 3. So what is EC? EC is equal to 3 divided by 1.5. What is 3 divided by 1.5? It is 2 centimeter. So EC is 2 centimeter. EC is 2 centimeter. Clear? Moving to the next problem. E and F are points on the sides of PQ and PR of a triangle PQR. So just consider a triangle PQR. So this is the triangle PQR. E and F are points on the sides PQ and PR. I'm marking the point E, marking the point F. Check whether EF parallel to QR. Check whether EF parallel to QR. Oh, I forgot one thing. I need to mark the lengths. So I will just check the textbook and I'm marking the values. Okay. So given PE is equal to 3.9 centimeter and EQ is equal to 3 centimeter. EQ is equal to 3 centimeter and PF is equal to 3.6 centimeter. Then FR is equal to 2.4. FR is equal to 2.4 centimeter. So these are the measurements. PE 3.9, EQ 3, PF 3.6 and FR 2.4. Now we need to check whether EF parallel to QR. Whether EF parallel to QR. Now I am drawing the line EF. We need to check EF is parallel to QR. If EF is parallel to QR, then the ratio of sides should be same. EF intersects PQ and PR at E and F respectively. If it is parallel to QR, then it divides the sides PQ and PR in the same ratio. So PE is 3.9, EQ is 3, PF is 3.6 and we need to find FR. So now I am taking the ratio. Whether it is same, then it is parallel to QR. If it is not same, then it is not parallel. Okay. Now I am going to check PE by PF. What is PE by PF? That is 3.9 by 3.6. This can be written as 39 by 36. That we can cut with 3. 13 into 3, 39. 12 into 3, 36. That we can write 13 by 12. 13 by 12. Now EQ by FR. FR is also given. FR is given as 2.4. FR is given as 2.4. So EQ by FR. EQ by FR. What is EQ? 3. What is FR? By 2.4. This can be written as 30 by 24. That is equal to 6 into 5, 30. 6 into 4, 24. So this is 5 by 4 and this is 13 by 12. Which is not same. Which is not same. PE by PF is not equal to EQ by FR. PE by PF not equal to EQ by FR. If it is not equal, if the ratio is not equal, then we can say that EF not parallel to QR. EF not parallel to QR. EF not parallel to QR. Okay. So for every problem we can check whether it is parallel or not. Just you have to find the ratio of the sides. If the ratio of the sides are same, then it is parallel. If the ratio of sides are different, then it is not parallel. Okay. That's all of the problem related to the first theorem. Now moving to the next theorem. Theorem number 2. If in two triangles corresponding angles are equal, then their corresponding sides are in the same ratio and hence the two triangles are similar. That means when we are considering two triangles and the corresponding angles of two triangles are equal, then their corresponding sides should be in the same ratio. Then we can say that these two triangles are similar. These two triangles are similar. So this is one criteria for similarity of triangles. This can also be stated in a reverse order. If in two triangles, if the corresponding sides are in the same ratio, then the corresponding angles are equal, and hence we can say that the triangles are similar. Next theorem is, if one angle of a triangle is equal to one angle of other triangle. So when we are considering two triangles and one angle of one triangle is equal to the one angle of other triangle, and if the including sides are proportional, then the two triangles are similar. So this can also be stated as, if one angle of a triangle is equal to one angle of other triangle and the including sides are proportional, or the including angles are proportional, then we can say that triangles are similar. Also this can be stated in other ways, in reverse order, that is, if one side of a triangle is proportional to other side of another triangle and the including angles are equal, then the triangles are similar. So theorems can be stated in reverse order also, no problem. The whole idea remains the same. So now we can do the problems related to this theorem. Okay, moving to the problems. In figure, triangle ODC similar to triangle OBA, that is ODC, this triangle. So this triangle is similar to triangle OBA. OBA is this one. These both triangles are similar. Angle BOC is given as 125 degree. This is 125 degree. And angle CDO is given as 70 degree. Find angle DOC, DCO and OAB. We need to find angle DOC. What is DOC? This one. And angle DCO, this one. And angle OAB, this one. So we know that for two similar triangles, the corresponding angles are equal. For two similar triangles, the corresponding angles are equal. So this angle should be equal to this one. Also this angle should be equal to this one. All the corresponding angles should be equal. We can find. So this is 125 degree. Vertically opposite angle should be equal. So this is also 125 degree. This angle and this angle should be equal. Total angle around a point should be 360 degree. So 125 plus 125 now becomes 250. So sum of these two angles is 110 degree. 110 divided by 2, this one is 55 degree. So angle DOC is equal to 55 degree. Now we can find the third angle. What is the third angle? 70, 55. What is 70 plus 55? 125. And the third angle is 180 minus 125, which is 55. So angle DCO equal to same 55 degree. Now for similar triangles, we know that corresponding angles are equal. So we can say that angle OAB is also 55 degree. Angle OAB is also 55 degree. So this angle is also 55 degree. This angle is also 55 degree. Clear? Moving to the next question. A vertical pole of length 6 meter cast a shadow 4 meter long on the ground. So we are having a vertical pole. This is the vertical pole AB. Cast a shadow 4 meter long. This is 6 meter. Casting a shadow. This is the shadow 4 meter long. Okay. Forms a triangle. And at the same time, a tower cast a shadow 28 meter long. I am considering a tower. This is the tower. A, B, C, D, E is the tower. Cast a shadow 28 meter long. 28 meter. D, E, F. For your convenience, I am making it as two figure. making it as two figure. In the same figure we can draw. In the same figure we can draw. This is pole. One is pole and this is the shadow. This is tower and this is the shadow. So I am making it as two figure for your convenience, for easy learning. So we need to find DE. We need to find D. Just consider these two triangles are similar triangles. If these two triangles are similar triangles, if this, by drawing the figure in this way, we know that the angle should be this one equal, this one equal. Then these two triangles are similar triangles. So for similar triangles, ratio side should be same. So AB by DE should be equal to AC by FE. So AB is given as 6 meter divided by DE we need to find is equal to AC is given as 4 by FE is given as 28. Now just cross multiply. 28 into 6 is equal to 4 DE. So DE is equal to 28 into 6 divided by 4. 6 and 4 can be cancelled. It becomes 3 and 2. 28 by 2 is 14. So what is 14 into 3? It is 42 meter. It is 42 meter. So what is the length of the tower? 14 into 2, 28. 28 plus 14, it's 42. So what is the height of the tower? It is 42 meter. Height of the tower is 42 meter. Okay, that's it. Now moving to the next theorem, which is related to area of similar triangle. The ratio of areas of two similar triangles is equal to the square of the ratio of their corresponding sides. So when we are considering two triangles, I am just considering two triangles. One is ABC and the next one is PQR. And I am saying that these two triangles are similar, then the ratio of areas of two triangles, that means area of triangle ABC by area of triangle PQR, this is the ratio of area of triangles, which is equal to the square of the ratio of their corresponding sides, that we can write AB by PQ the whole square, which is equal to BC by QR the whole square, which is equal to AC by PR the whole square. Any side you can take, just remember ratio of areas of two similar triangles is equal to the square of ratio of corresponding sides. So three corresponding ratios are there because three sides are there for a triangle. So you can take any one side, because in the problem which side is given, take the ratio of that side. That's it. If AB and PQ are given, then AB by PQ the whole square. If BC and QR are given, then BC by QR the whole square. If AC and PR are given, then AC by PR the whole square. Anyway, area of similar triangles, the ratio should be equal to square of ratio of the corresponding sides. That's it. This is the theorem. Now, moving to the problems related to the theorem that we have studied right now. Let triangle ABC similar to triangle DEF. So here we are having two triangles, that is triangle ABC and triangle DEF, and in the question it is given that these two triangles are similar and their areas are 64 centimeter square and 121 centimeter square. That is, area of triangle ABC is equal to 64 centimeter square and area of triangle DEF is equal to 121 centimeter square. If EF is equal to 15.4 centimeter, find BC. EF is given as 15.4 centimeter. We need to find BC. So by theorem we know that area of triangle ABC divided by area of triangle DEF, which is equal to square of the ratio of corresponding sides, that we can take BC by EF the whole square. So area of ABC is given as 64 by area of DEC is given as 121 is equal to, we need to find BC by EF is given as 15.4 the whole square. Okay. So we need to find BC from here. We need to find BC from here. How we can find BC? So 64 can be written as 8 square by 121 can be written as 11 square is equal to BC by 15.4 the whole square. Right? 8 square by 11 square can be written as 8 by 11 the whole square is equal to BC by 15.4 the whole square. In both sides square can be cancelled. Then cross multiply. 15.4 into 8 is equal to 11 BC. Then what is BC? BC is equal to 15.4 into 8 divided by 11. That we can calculate. 15.4 into 8. 8 into 4, 32, remainder 3. 8 into 5, 40. 40 plus 3, 43, remainder 4. 8 into 1, 8. 8 plus 4, 12. So 123.2 divided by 11. That can be written as 1232 divided by 110. So 1232 divided by 110. So 1 into 110, 110, remainder 13, 132, 1 times 110, remainder 22.0. So 110 into 2, 220. So the answer is 11.2 centimeter. So the answer is 11.2. So what is BC? BC is 11.2 centimeter. BC is 11.2 centimeter. Okay. Now moving to the next problem. What is the next problem given? If the areas of two similar triangles are equal, then prove that they are congruent. If the areas of two similar triangles are equal, then prove that they are congruent. So here also I am considering two triangles which I am taking the same figure. Not rubbing this, I am taking the same figure. ABC and DEF are the two similar triangles. ABC and DEF are the two similar triangles. And in the question it is given that the areas are equal. That means area of ABC is equal to area of DEF. Area of triangle ABC equal to area of triangle DEF. Area of triangle ABC equal to area of triangle DEF. Now by theorem we know that ratio of these areas should be equal to the square of the ratio of the corresponding sides. So I can write area of triangle ABC divided by area of triangle DEF is equal to, take the corresponding sides, AB by DE the whole square, which is equal to AC by DF the whole square, which is equal to BC by EF the whole square. So we know that area of triangle ABC and area of triangle DEF should be equal. If they are equal, the answer should be 1, because if it is taken as x, x by x is 1. So that is equal to AB by DE the whole square. What happens? If AB by DE the whole square equal to 1, AB by DE the whole square equal to 1. For AB by DE the whole square to be 1, What is the condition? AB should be equal to DE. AB should be equal to DE. In the same way, AC by DF the whole square equal to 1. So we can say that AC should be equal to DF. Also, BC by EF the whole square should be equal to 1. So we can say that BC should be equal to EF. That means all the three sides of one triangle is equal to all the three sides of other triangle. If all the sides are equal, then they are congruent. If all the sides are equal, then they are congruent. So we can say that if the area of two similar triangles are equal, then these triangles are congruent. Then these triangles are congruent. Simple. Okay. Now the last topic of this chapter is Pythagoras theorem. Last topic of this chapter is Pythagoras theorem. What is Pythagoras theorem? First, basically you need to understand, you need to know that this Pythagoras theorem can be applied only to right-angled triangles. This Pythagoras theorem can be applied only to right-angled triangles. What do you mean by a right-angled triangle? Right-angled triangle means any one of the angle should be 90 degree. Any one of the angle should be 90 degrees. So here I am considering a right-angled triangle. This is 90 degree. The side opposite to 90 degree is known as hypotenuse of the triangle. The side opposite to the triangle. Side opposite to the right angle. Side opposite to the right angle is known as hypotenuse. And this side is known as the base. And the height of the triangle is known as the altitude. Height of the triangle is known as the altitude. So when we are considering a right angled triangle, only to a right angled triangle we can apply Pythagoras theorem. Okay. So here ABC is a right angled triangle. The side opposite to the right angle or 90 degrees the hypotenuse. And this AB is the base and the height of the triangle is known as altitude. So Pythagoras theorem states that the square of hypotenuse should be equal to sum of the squares of base and altitude. Sum of the squares of base and altitude. So we can write hypotenuse square equal to base square plus altitude square. This is Pythagoras theorem. Hypotenuse square equal to base square plus altitude square. This is Pythagoras theorem. So here hypotenuse is BC. So BC square is equal to base is AB. AB square plus altitude is AC. AC square. So hypotenuse square equal to base square plus altitude square. That is BC square equal to AB square plus AC square. This is Pythagoras theorem. Now we need to solve problems using this Pythagoras theorem. That's our last topic. Okay. When we are solving problems by using Pythagoras theorem, the chapter is complete. That all things you have to study from this chapter. Proofs are deleted from this chapter. Already in the current syllabus 2022-2023, that means 22-23 syllabus, just check your syllabus that for your board exam, proofs are deleted. So only in problems like prove that they are congruent that we have solved right now, like that problems are there. Proofs for theorems are deleted. So study the theorem well and study all the problems related to that theorem. Then you can score well in this chapter. Okay. Look at the questions related to the Pythagoras theorem. First one is, a ladder 10 meter long reaches a window 8 meter above the ground. So we need to consider a ladder. So I am considering a ladder. This is the ladder and I am naming it as AB. This reaches the window. So window should be on the wall. AC is the wall. We need to find the distance of the foot of the ladder from the base. So this BC we need to find. And the length of the ladder is given as 10 meter, reaches a window 8 meter above the ground. So this is 8 meter. We need to find BC. How we can find BC? Just apply Pythagoras theorem to this triangle. What is Pythagoras theorem? Hypotenuse square is equal to base square plus altitude square. So what is hypotenuse? AB is hypotenuse which is given as 10. 10 square is equal to BC is base which we need to find BC square plus altitude is AC which is given as 8 square. So BC square is equal to 10 square minus 8 square. That is 10 square is 100 minus 8 square is 64, which is 36. So BC is equal to root 36, which can be written as 6. So 6 meter. Distance of the foot of the ladder from the base of the wall is 6 meter. Root 36 can be taken as plus or minus 6. That in the quadratic equation chapter we studied that for all roots, two values are there, positive and negative. For root 36, it is actually the answer is plus 6 or minus 6. But here I didn't take the negative. Why? Because it is a distance. Distance cannot be negative. That's why I am taking only the positive value. So the distance between foot of the ladder and the base of the ground is 6 meter. By applying Pythagoras theorem, we can easily find. So next is a triangle. Next is a question. ABC is an isosceles triangle with AC equal to BC. If AB square is equal to 2AC square, prove that ABC is a right triangle. So I am considering ABC is an isosceles triangle. Just I am considering the triangle ABC. This is the triangle ABC. With AC is equal to BC. AC and BC are equal. I am taking AC as X. Then BC is also X. If AB square is equal to 2AC square, prove that ABC is a right angled triangle. So now we don't know whether it is a right angled triangle or not. Let us assume that this is a right angled triangle. Then we can apply the Pythagoras theorem. If the Pythagoras theorem is satisfied here, then it is a right triangle. If the Pythagoras theorem is not satisfied here, then it is not a right angled triangle. That's it. So let us assume that, first assume that ABC is a right angled triangle. Assume ABC is a right triangle. If it is a right triangle, Pythagoras theorem should be satisfied. Otherwise, not. If Pythagoras theorem is satisfied, then it is a right triangle. We need to prove it is a right triangle. So what is Pythagoras theorem? Hypotenuse square equal to base square plus altitude square. So what is the hypotenuse? Hypotenuse square is equal to base square plus altitude square. So just I am taking AB as the hypotenuse. I don't know whether it is right or not. If it is satisfies, it is right angle. Otherwise, it is not right angle. So AB square equal to longest side in a triangle is its hypotenuse. Here AC and BC is same, X given. So we should take AB as the hypotenuse. AC and BC are equal. It is given in the question. So AB should be the hypotenuse, whether if it is a right angle triangle. So AB square is equal to AC square plus BC square. That is AB square is equal to AC can be written as X square plus X square. That is AB square is equal to 2X square. What is X? X is actually AC. So we can write AB is equal to 2 into, in place of X I am writing AC, 2AC square, which is the condition given in the question. AB is equal to 2AC square. So when we are applying Pythagoras theorem to this triangle, we get correct. AB is equal to 2AC square. That means here AB is the hypotenuse. So here AB is the hypotenuse. So I am redrawing the figure as a right triangle. And AB is the hypotenuse. So this is the hypotenuse. And AC and BC are equal. This is the condition. So now we can say that ABC is a right triangle. So that's the proof. Okay. So in this chapter, mainly 4 sections we discussed. First one, that a line segment is parallel to one side of a triangle. Then it intersects other two sides in the 2 points, and this line segment divides other two sides in the same ratio. That's the first theorem we discussed. Second one is related to the similarity of triangles, that we said that if the corresponding angles of two triangles are equal and the including sides are equal, or in the including sides are proportional, then we can say that these two triangles are similar. Two triangles are similar. And in the third section, we discussed about the area of similar triangles. The area of two similar triangles, when we are considering the ratio of areas of two similar triangles is equal to the square of the ratio of corresponding sides. And in the fourth section, we discussed Pythagoras theorem. That's all about the chapter triangles. For each section, we discussed the problems also. So when you are studying after watching the video, just by heart the theorems that we have discussed here, and just take the examples of problem I solved here, and using that example you can try to solve all other problems. Okay, so study well and be prepared for the board exam. Score well. If you score well, that's our happiness, that's our success. Okay, so I am Nidishas right now signing off. Let us meet with another chapter in another day. All the best for your studies. Keep learning. That's all.